We are starting with integration by parts, Indef 2. Okay. So in integration by parts, the basic formula is integration of u into v dx. That is u integration v dx, bigger integration dy dx of u, smaller integration v dx, bracket close dx. Okay. So this integration by part follows light or islet rule. So I'll stick to light. L is logarithmic terms, I is ITF terms, A is algebraic terms, x raised to n, T is trigonometric term, trigonometric functions, TF, sine, cos, and so on and so forth. E is exponential form, exponential terms, e raised to x and e raised to x. Okay, so the terms u and v should be as per this order. Okay, that I'll explain while solving the problems. 14C question number 1. Integration of x sine 2x dx. Now x is x raised to 1, which is algebraic term. Okay, x raised to n, algebraic term, and this is trigonometric. So LIATE, algebraic and trigonometric. So it is as per the order. So we need not reshuffle this. Okay, so the first term becomes u and the second term becomes v. This is u and this is v. So u integration v dx, bigger integration dy dx of u dx, dy dx of u, integration of v dx, bracket close dx. So u is x, integration of sine 2x, dy dx of x, integration of sine 2x dx, bracket close dx. So x integration of sine is minus cos 2x upon 2. There is 2 in the denominator because of the chain rule. Chain rule in integration, okay? This is 1 minus cos 2x upon 2. Minus into minus will be plus because there is multiplication after 1. And this 2 will go out. So minus x cos 2x upon 2 plus half outside integration cos 2x dx. So minus x cos 2x upon 2 half integration of cos 2x is plus sin 2x upon 2. So this is the end of the problem. The only thing that you need to do is 2 and 2 you need to multiply. Okay. Second problem. Integration of x sec square x dx. So x is x raised to 1. So this is algebraic. Sec square x is trigonometric function. It's not an ITF, it's a TF. So it is as per the priority list LIATE. No need to change this. No need to reshuffle this. Okay. So this is u and this is v. Write down the formula clearly. U integration v dx. Bigger integration. Bigger integration should look like bigger integration. Box bracket should always be there. Don't miss out on this in instructions. Minus bigger integration dy dx of x sec square x dx. So x into tan x, bigger integration 1 into tan x. Okay. Integration of sec square x is tan x. Now this part 1 into tan x is tan x. So tan x is log mod sec x. That formula you know. So that you can put it over here and end the problem. Question number 3. Integration of x square e raised to x dx. Okay, so this is algebraic and this is exponential term. So u and v, no need to interchange this. So u integration v dx minus bigger integration dy dx of x square e raised to x dx bracket close dx. So x square e raised to x minus 2x e raised to x dx. X square is 2x, e raised to x is e raised to x. Now take that 2 outside into x e raised to x dx. So again, this is going to be u into v, but then that calculation, you please do in a curly bracket like this, and towards the end, you can multiply this minus 2 with whatever terms are there in the curly bracket. But again, you have to apply the u into v, that is integration by parts formula. Okay, question number 4, you can do it for self study. Question number 5, integration of 1 plus x cos 2x dx. This is algebraic term, trigonometric term, so u and v. So 1 plus x integration of cos 2x minus bigger integration d by dx of 1 plus x integration of cos 2x dx bracket close dx. 1 plus x cos 2x is sin 2x upon 2. Derivative of 1 plus x is 1, and this is sin 2x upon 2 dx. So 1 plus x sin 2x upon 2 minus half integration of sin 2x. Now integration of sin 2x is minus cos 2x upon 2. Okay, but then write this thing within a bracket like this. Okay, now this minus and this minus will be plus, and 2 into 2 will be 4. So all these things you do. That's pretty simple. Okay, so after this, just integrate sin 2x. Let's go to question number 6. Integration of 1 minus x square log x dx. Okay, now this is logarithmic term and this is algebraic term. As per the priority list, logarithmic comes before algebraic. So just reshuffle it. Log x into 1 minus x square dx. So this is u and this is v. So u integration v dx minus bigger integration d by dx of log x integration of 1 minus x square dx bracket close dx. Now integration of 1 minus x square is x minus x cube by 3. Integration of 1 minus x square x minus x cube by 3. Okay, so this and this will be x minus x cube by 3, log x will be 1 upon x, derivative part. Okay, so this log x is as it is, x minus x cube by 3, bigger integration 1 upon x minus x cube by 3. So this is x minus x cube log x by 3 minus 1 by 3 outside, 1 by 3 outside, x minus x cube by x. Okay, x upon x is 1 and x cube upon x is x square. Now again, this is individual integration that you do within the box bracket. Okay. Question number 7. Integration of x square sin x dx, algebraic and trigonometric. Okay, so we need not change the order. Algebraic and trigonometric, it's the order is quite fine. So u and v, u is x square, v is sin x. So u integration v dx, bigger integration dy dx of x square sin x dx bracket close dx. X square cos x dx, sorry, it's minus cos x, and no dx will come. 2x into minus cos x. Okay, so this is minus x square cos x, minus into minus will be plus 2 outside x cos x. Now again this is going to be u into v because it's algebraic and trigonometry. So whatever integration you do within this curly brackets. Again you'll have to apply that bigger formula, integration by parts formula. Okay, that I'll leave it up to you. Now let's understand this integration of log x dx. Now there is no formula for log x. There is no formula for log x in integration. So log x into 1 dx. So log x into 1, log x integration of 1 dx. So this is u and v is 1. Bigger integration d by dx of log x, integration 1 dx bracket close dx. Log x into x, 1 upon x into x dx. So this and this is gone. So the final answer will be x log x minus integration of 1 is x plus c. Okay. So this extra problem you should know. Log terms, how to tackle it, that you should know. Eighth problem, integration of log x the whole square. So we'll write this as log x the whole square into 1 u into v. Log x the whole square, integration of 1 dx, dy dx of log x the whole square, integration 1 dx, bracket close dx. Log x the whole square into x minus derivative of log x the whole square, 2 log x raised to 2 minus 1 dy dx of log x, and integration of 1 is x. So x log x the whole square minus box bracket 2 log x dy dx of log x is x, and this integration of 1 was x, which will get carried forward over here. Okay, so now x got cancelled. Take this 2 outside over here. So we are left with log x into 1. So this is u and this is v. So it will be minus 2, and this part log x into 1, that integration part you have to do within the curly bracket. Okay, the first term will remain as it is throughout the problem. This will remain as it is without any change. But then after taking 2 common over here, 2 outside over here, constant goes outside the integration. This part you solve using light rule or integration by parts. Question number 9. Integration of 2x e raised to 5x dx. So you can take 2 out also, otherwise this is algebraic along with 2. 2x together is algebraic, and this is exponential. Okay, so this is u and this is v. No need to interchange this. U integration v dx, bigger integration dy dx of 2x, integration of 5x dx bracket close dx. So this is 2x e raised to 5x upon 5, 2 by 5 outside being a constant, integration of 5 dx. Now this you can solve e raised to 5x upon 5. So overall this will be 2 by 25 in the last, in the ultimate step. This will be 2 by 25 once you integrate e raised to 5 then. Okay. So this is pretty simple. I'll leave it up to you. Question number 10, integration of log 1 plus x square upon x square. So integration of log 1 plus x square into x raised to minus 2 dx. So log 1 plus x square x raised to minus 2 dx. Okay, I'll just clarify this. Logarithmic and algebraic. So this is u and this is v. The order is also perfect. Logarithmic comes before algebraic. So we need not interchange this. We need not swap this. D by dx of log 1 plus x square integration of x raised to minus 2 dx. So log 1 plus x square. Let me solve the integration of x raised to minus 2 over here. Okay, now this part is very important. Minus 2 plus 1 upon minus 2 plus 1. Okay, so this will be minus 1 upon x. So wherever you see x raised to minus 2 integration, just put minus 1 upon x. Okay, again and again you don't solve in this problem. 1 upon 1 plus x square, derivative of this, into dy dx of 1 plus x square. Dy dx of 1 plus x square is 2x. And integration of x raised to minus 2 is minus 1 upon x dx. So this x and this x is gone. This minus and this minus will become plus. Okay. So minus log 1 plus x square upon x plus integration. We are left with 2 over here. Minus minus became plus. 2 outside. 1 upon 1 plus x square. Now this is a direct formula. This is tan inverse x that you can substitute plus c. Okay. Question number 11. Integration of x square log x dx. Okay, so this is log and this is algebraic. The order is not correct. First log term should be there and then algebraic as per light rule. First log and then algebraic. So rearrange this, then this will become u and v. Okay. Now you can solve this on your own. It is very simple. You don't require any assistance over here. Question number 12. Okay, so one thing I would like to clarify, log x square to the base e is nothing but log x square. It is understood that the base is e, its natural log. So this will be 2 log x. Value raised to power goes ahead. If it is like this, then this 2 cannot go ahead. Okay, if the log has a power, that power does not go ahead. Okay, so the question is x cube log x square to the base e. So x cube into 2 log x. 2 outside, write log x term first because this is logarithmic and this is algebraic. So logarithmic term should be first. So after 2, put a curly bracket and put the formula of integration by parts and solve this. Okay. That was your question number 12. Question number 13, a very interesting problem, I should say. Okay, so x sine square 3x. Now in Indef 1, we have already learned that whenever there is sine square cos square, we have to multiply and divide with 2. So that is very essential over here. So multiply and divide by 2. Okay. In case of sine square and cos square. Now 1 minus cos 2x is 2 sine square x. So 1 minus cos 6x. 2 sine square 3x. So what is 2 sine square 3x? 2 sine square 3x is 1 minus cos 6x dx. So this is I. Okay. So half integration of x minus x cos 6x dx. Integration of x is x square by 2 minus integration of x cos 6x dx. So guys, what I've done is I've just integrated the first part. Second part, I'm just keeping it as it is. Okay. This is I. Second part, I'll keep it as it is. I'll mark this as equation number 1. Now I'll solve the second part separately. X cos 6x. Now here that formula will come u into v. This is algebraic, this is trigonometric. No need to interchange, no need to swap. So you solve this on your own, and whatever answer you get, you put it over here. But then that you put within a box bracket because there is a minus sign outside. Okay. So be extra careful over here. Question number 14. Integration of x minus sin x 1 minus cos x. X minus 2 sin x by 2. Okay. Half angle over here. 2 sin x by 2 cos x by 2 x sin x will become. And 1 minus cos 2 sin square x by 2. Now split x upon 2 sin square x by 2 minus this. So 2 gone, sin gone. So it will be cot x by 2. Okay. Right. So this is how we solve by splitting. Then take this sin square up. So this is equal to x cos x square x by 2 upon 2 minus cot x by 2 dx. Okay. Now let this be I1 and let this be I2 because we have not integrated cot as of now. So I1 is this wherever I've written I1. Okay. Now how to solve I1? You can take half outside. Then u into v because integration of cos x square is minus cot. Okay. You can take u into v over here. See, brackets and everything should be very much in place. Okay. Now solve I1 and let us mark this as equation number 1 before that. Okay. So solve I1 separately, solve I2 separately, and then subtract both. Now I2 is cot x by 2. We have a direct formula for cot. Okay. Let's go to 15th problem. Question number 15. Integration cos inverse x dx. Now, even in the case of ITF, there is no direct integration formula. So in logarithmic problems and in ITF problems, what you need to do is you need to take V as 1 because there is no direct formula over here. Okay. So take V as 1 and solve. So this is cos inverse x, V is 1, dy dx of cos inverse x, integration of 1 dx, bracket close dx. Okay. Cos inverse of x into x, derivative of cos inverse x is root of minus 1 upon root of 1 minus x square into x. Okay. Now this minus and this minus will be plus. So x cos inverse x plus x upon root of 1 minus x square. Now this is pretty simple. See, the derivative of this term within the root is minus 2x. So we just have to make this minus 2x. Multiply and divide with minus 2. X cos inverse x. Divide with minus 2. Multiply with minus 2. Okay. So f dash x upon root f of x. F dash x upon root f of x is 2 root f of x. It's 2 root f of x. X cos inverse of minus half 2 root f of x. Now this 2 and this 2 will get cancelled. Okay. F of x is 1 minus x square. That will put it over here. In this properties, there is no chain rule. Huh? F dash x upon f of x, f dash x upon root f of x. This properties, there is no chain rule. Question number 16. Integration of cot inverse x dx. Cot inverse of x into 1. So this is u and this is v. Cot inverse of x into 1 dx. Bigger integration. dy dx of cot inverse x into 1 dx. Cot inverse of x into x. Integration derivative of cot inverse x is minus 1 upon 1 plus x square. Integration of 1 is x. So now this minus and minus you make it plus. Minus and minus you can make it plus. So x cot inverse x plus x upon 1 plus x square dx. Now the derivative of the denominator over here is 2x. So we'll just multiply and divide with 2. X cot inverse x multiply and divide with 2. So this is f dash x upon f of x. So x cot inverse x plus half log mod x. Okay. The value of f of x is 1 plus x square. That you can substitute over here. Question number 17. Integration of cosec inverse x. So cosec inverse x into 1 dx, u and v. Cosec inverse x, integration of 1 dx, bigger integration. dy dx of cosec inverse x into integration of 1 dx bracket close dx. So cosec inverse x, integration of 1 is x, bigger integration. dy dx of cosec inverse x is minus 1 root x square minus 1 and this is x. Okay. So now this and this term will get cancelled. We are left with dx. Now this minus and this minus will be plus. Okay. So x cosec inverse x plus 1 upon root of x square minus 1. Now this formula is a part of Indef 3. Okay. Had it been root of 1 minus x square, this is nothing but sine inverse x. This is a direct formula which I have given you. But in this x square minus 1, we'll have to solve using Indef 3. Okay. Let's go to question number 18. X square cos inverse x dx. So this is ITF and this is algebraic. LIAT. Cos inverse is ITF. ITF then algebraic. So we need to change the order. Cos inverse x into x square dx. So this is u and this is v. Cos inverse x square dx. dy dx of cos inverse x square dx. Okay. Cos inverse of x cube by 3 minus 1 root of 1 minus x square x cube by 3. Now this minus and this minus will be plus, take 1 by 3 outside. So x cube cos inverse x by 3 plus 1 by 3 integration x cube upon root 1 minus x square. Okay, x cube upon root 1 minus x square. Now let this be I1. I1 is equal to x cube root 1 minus x square dx. So I'll just write this as x square into x. X cube is x square into x root 1 minus x square dx. Put 1 minus x square equal to t. So this part is equal to t. Okay, method of substitution. So derivative of this is minus 2x equal to dt by dx. Now look at the step above. So x dx will be dt by minus 2. So x dx will be dt by minus 2, that I'll write on the next page. Okay, then down, this term is t. So this is going to be root t. And up, there is one more term left. Now what is left over here? X square. So x square is equal to 1 minus t. X square is equal to 1 minus t. Okay, you can take minus 1 upon 2 outside because minus 2 is over here. 1 minus t raised to half. 1 upon t raised to half minus t raised to 1 upon t raised to half. So t raised to minus 1 by 2. 1 minus half is minus half dt. Okay, minus half plus 1 is half upon half. And this is half. Okay, sorry. T raised to 3 by 2 upon 3 by 2 plus c1. So this is I1. I'll give you hints. Take this 2 up over here, then take it common and cancel with this 2. That's how you manage those 2's over there. Put the value of t as 1 minus x square. That is what you have taken in the problem. And once you calculate I1, put the value of I1 in equation number 1 here. Okay, so this part I think you people have to manage. Question number 19. Integration of sine root x dx. Now we cannot compare this with sine x because x will be root x. So root x is not linear algebraic term. X power is half. X power is not 1. So I'll just put root x is equal to t dy dx of root x dy dx of t 1 by 2 root x dt by dx. Okay. Now there is no 1 by 2 root x in the problem. It's only sine root x. And this to became t. This is t. So these terms are not there only in the problem. So see how we have to manage these terms. So dx is equal to 2 root x dt. Now we know the value of root x. Root x is nothing but t. So this will be 2t dt. Dx will be 2t dt. Okay. So I sine root x is t and dx is 2t dt. 2 outside, algebraic, trigonometric, write algebraic term first. As per the light rule, LIAT, algebraic comes first. Now you do u into v. Okay, so 2 u integration of v dt. Now don't write dx, write dt. dy dx of u, dy dt of u, integration v dt, bracket close, dt. and then curly bracket close. So you can put these values over here, integrate it with respect to t, and towards the end, once you simplify everything, you can put the value of t as root x. Next problem, that is question number 12, or sorry, 20. It's on the similar lines. Tan inverse root x dx. Put root x is equal to t. D by dx of root x. D by dx of t. 1 by 2 root x dt by dx. Dx is equal to 2 root x dt. Now root x is t. Okay. So I tan inverse t, tan inverse t dx is 2t dt. So 2 outside, tan inverse t into t dt. Okay. ITF algebraic. So no need to swap this. We can just take this as u and this as v. So 2 tan inverse t integration of t dt, bigger integration d by dt of tan inverse t integration of t dt, bracket close dt, 2 tan inverse t integration of t is t square by 2, bigger integration tan inverse of t 1 by 1 plus t square, and this is t, so t square by 2. Okay, dt. So 2 t square tan inverse t by 2 minus half t square upon 1 plus t square dt. Now the maximum degree of the numerator and the maximum degree of the denominator is same. So if the degrees are same, make numerator same as denominator. Okay. So I'll just show you how to do this. You can do it on your own later on. Okay. So what we have to do is this part I'll just show you. T square upon 1 plus t square. So add and subtract 1. Make numerator same as denominator. Now split dt, this will be. Okay, now this is direct integration. Integration of 1 is t and this is tan inverse t. Okay, so this value we got t minus tan inverse t. So this will be half into, put a box bracket over here. This value will be after integrating t minus tan inverse t. Now once you do this, write plus c over here and then put the value of t. That was your question number 20. We'll proceed further and let's go to question number 21. Integration of log x upon x square dx. So log x into x raised to minus 2 dx. This is u and this is v because it's logarithmic and algebraic. X raised to minus 2 is x raised to n. So it's algebraic, logarithmic and algebraic. Okay. So u integration of v dx minus bigger integration d by dx of log x integration of x raised to minus 2 dx bracket close dx. X raised to minus 2, sometime back we have done, it is minus 1 upon x. Don't write it directly. You have to show the working note why it is minus 1 upon x. Okay. X raised to n formula in integration. 1 upon x into minus 1 upon x. So minus log x upon x. Okay. Minus into minus is plus. 1 upon x square. This x square you take it up in the numerator. This is going to be x raised to minus 2 once again. And this also eventually will be minus 1 upon x. Okay. That was question number 21. Let's go to question number 22. Integration x sine inverse x dx. So this is ITF and this is algebraic. So sine inverse x into x dx. Okay. Why we interchange this? Because ITF comes before algebraic. So this is u and this is v. dy dx of sine inverse x. Okay. Sine inverse x is 1 upon root of 1 minus x square and this is x square by 2. Okay. Now, again, we can take this half outside. Okay. So x square sine inverse x by 2. X square upon root 1 minus x square. Now, since the degree is same, 2 and 2, it is same. Make numerator same as denominator. So multiply and divide with minus first. So x sine inverse x by 2 plus 1 by 2. 1 minus x square minus 1. Root 1 minus x square. Okay. So this upon this minus this upon this. Okay. So x sine inverse x by 2 plus half. Okay. 1 minus x square upon root 1 minus x square minus this. Okay. Now x upon root x is root x. Okay. That concept I'll apply over here. Okay. So this is going to be x sine inverse x by 2 plus half root 1 minus x square minus. Okay. Now this is I1 and this is I2. Now I2 is very easy because this is a direct formula sine inverse x. But then I1 will be covered up in Indef 3. It is root of a square minus x square formula. Okay. Let's go to question number 23. It's a very simple problem. Log of log x upon x. Log of log x into 1 by x dx. Put log x equal to t. Now this x I have written it as 1 by x. Okay. dy dx of log x. dy dx of t. So 1 upon x is equal to dt by dx. So 1 upon x dx equal to dt. Okay. So in equation number 1, this is going to be dt and this is going to be t. Okay. So integration of log t into dt. So log t into 1. Now you can solve this. We have discussed this earlier also. Fine. Let's go to the next problem. Question number 24. Sine cube root x dx. So first put root x is equal to t. dy dx of root x. dy dx of t. 1 upon 2 root x dt by dx. Okay. 2 root x dt. Dx is equal to 2 root x dt. Okay. So now see, this root x is not there in the problem because this is going to be t But then where will I get one more root x? 2 root x dt. Something like there is not there. 2 root x is not there in the problem. So this root x you replace it by t. Okay, so this will be sine cube t, sine cube t, and dx is 2t dt. You can take 2 outside. This is algebraic and this is trigonometric. Sine cube is trigonometric. So t into sine cube t. Multiply and divide with 4. So whenever cube is there, we multiply and divide with 4. Okay, this we have learned in Indef 1. Okay, so this is going to be half t 4 sine cube t. Okay, now see sine 3x, 3 sine x minus 4 sine cube x. So 4 sine cube x, 3 sine x minus sine 3x. So half t 4 sine cube t will be 3 sine t minus sine 3t into dt. Okay, right? So now t you multiply with both. So I is equal to half t into 3 sine t minus t into sine 3t dt. So this is I1 and this is I2. Now when you solve I1, take 3 outside, t sine t, algebraic trigonometric. So UV rule. When you solve I2, t into sine 3t, algebraic trigonometric. This is sine 3t, yeah? It's not sine cube t, sine 3t. Okay, algebraic and trigonometric. Okay, so you solve I1 and I2 separately and put it in equation number 1. Next problem, 26 x cos cube t. Now again there is cube, multiply and divide with 4, multiply and divide with 4. I think I multiplied x over here. Okay, now cos 3x, 4 cos cube x minus 3 cos x. Therefore 4 cos cube x cos 3x plus 3 cos x. So 1 by 4 x cos 3x plus 3 cos x dx. Okay, 4 cos cube x value are 4. Now this is like the previous problem. You multiply x with this, you multiply x with this. Okay, you get two different parts. You have to take I1 and I2 and solve individually I1 and I2 separately. Okay. So see, Indef 1 is also coming into picture. 27 x tan square t, x tan square x dx. Now in Indef 1, tan square and cot square, I have given you a clear cut instruction. Whenever tan square and cot square comes in the problem, use sec square x minus 1. So integration of sec square x minus 1, sorry, x into sec square x minus 1. Split this, or rather multiply x with both. This is I1 and this is I2. I2 is very simple. Integration of x will be x square by 2, and integration of x into sec square x will again be u into v. So solve I1 and I2 separately and put in equation number 1. Question number 28. Integration x sec 2x minus 1 sec 2x plus 1 x 1 upon cos 2x plus 1 minus 1 and this is plus 1. Okay. So 1 minus cos x cos 2x upon 1 plus cos 2x. Take LCM so that cos 2x term in the denominator will get cancelled out. Okay. So this is going to be x 1 minus cos 2x 1 plus cos 2x dx. So x 2 sin square x 2 cos square x. So x tan square x. Now tan square x again you have to write sec square x minus 1. Now this is like question number 27. Tan square x put sec square x minus 1 and proceed. Question number 29. Integration of tan inverse of 2x upon 1 minus x square. So this is 2 tan inverse x. It's a direct formula of ITO. So 2 tan inverse x, inverse trigonometric function, so v will be 1. So you solve this within curly bracket, you'll get the derivative of it. Okay. Integration of it. Okay. Question number 30. Integration of cos inverse 1 minus x square 1 plus x square. This again is 2 tan inverse x. So this part you can solve it on your own. Now this is a direct ITF formula, you can use it. Okay. Question number 31. Integration of tan inverse x square into x dx. Now derivative of x square is x, which is present in the problem. So put x square equal to t, dy dx of x square is equal to dy dx of t. Okay. So 2x is equal to dt by dx. So x dx is dt by 2. X dx. Okay. So I is equal to, this became dt by 2 and this is tan inverse t, half outside, tan inverse of t into 1. So this is u and v. Okay. Question number 32. Integration of sec inverse root x dx. Okay, sec inverse root x dx. Now put root x is equal to t, dy dx of root x, dy dx of t, 1 by 2 root x dt by dx. So dx is equal to 2 root x dx. Now this root x is nothing but t. So this is going to be 2t dt. So I integration of sec inverse, this is t and dx is 2t dt. So 2 outside, sec inverse of x into t dt, this is u and this is v. So put this in the formula, 2 sec inverse of t into t integration of t dt, bigger integration dy dt of sec inverse t integration of t dt, bracket close dt, sec inverse of t, t square by 2 integration of sec inverse t is plus 1, sorry, it's plus 1, x root x square minus 1 or t root t square minus 1, sorry. This is t root t square minus 1 and this is t square by 2 dt. So 2 t square sec inverse t by 2 minus half. This will go outside, half will go outside. T square and t is gone. So t upon root of t square minus 1 dt. Now this is very simple. You just have to multiply and divide with 2 because the derivative of this is 2t. So after you multiply and divide with 2, it is going to be f dash t upon root f of t. That is 2 root f of t. And then resubstitute the value of t as root x. Okay. Let's go to question number 33. Question number 33. Log sec inverse of x root x square minus 1. So I'm just giving you the hint. Take this term as t because the derivative of sec inverse x is 1 upon x root x square minus 1. And then you'll get something like this, integration of log t dt. So log t into 1. Okay. 34, integration of e raised to x 1 plus x log x into e raised to x. Again, I'm giving you hint. Take this term as t because the derivative of this by UV rule will be this. So this along with dx will be dt. Okay, so you have to do those steps. 35, integration of sine inverse 3x minus 4x cube. Now this is 3 sine inverse x. It's a direct ITF formula. 3 sine inverse x. So you take 3 outside, sine inverse x into 1. Okay, so this I leave it for you. This was a direct formula, 3 sine inverse x. Then 3 outside, sine inverse x into 1 because whenever there is ITF, v is 1. Okay. And the last problem, that is question number 36. Integration of x square tan inverse x 1 plus x square dx. Now put tan inverse x is equal to t. dy dx of tan inverse x is 1 upon 1 plus x square and dy dx of t is dt by dx. So 1 upon 1 plus x square dx is equal to dt. Okay, so dx upon 1 plus x square, dx upon 1 plus x square became dt. Tan inverse x became t. Okay, so we are left only with x square. So we have to manage that particular term. So first tan inverse x, I'm just putting it as t. Dx upon 1 plus x square is dt. Okay, now x square is left. Now if tan inverse x is equal to t, so x is equal to tan t. So x square is equal to tan square t. X square is equal to tan square t. So this will be tan square t into t dt. Okay. Now this is similar to question number 27, which we have solved. Tan square is sec square minus 1 that you need to do. Multiply t with both the terms and solve. That is the end of exercise 14C.